sheet. So we're starting off with questions 5 through 10, 1 through 5 are bonus points. I will cover 2 of them on the full video. I'm not going to cover many of them in class because they are purely for bonus. And they're worth 1 point apiece. There are 3 that I left on the test, mainly because I printed the test before I changed that. I need to stop doing that. But if you do get all the transformations for each one of those, you do get the full point. But you got to get all of them to get the full point. So it's all or nothing on those. I did cover them in the full video, so I will post that later today. But this is where we're really going to start, or on these here. We want to find the vertex and axis of symmetry. Now for these here, there's 2 different types that we have. Really there's 3, but there's going to mainly be focused on these 2. Standard form and vertex form. Now problem number 6 is in vertex form. Our y equals, or f of x equals a times x minus h squared plus k. And we want to find the vertex and the axis of symmetry. Now the vertex is the point h comma k. And the axis of symmetry for this here is x equals h. Now, what's the value of h for this here? 2. Because x minus 2, our h value would indeed be positive 2. Our k value would be 5. So the vertex is the point 2, 5. Axis of symmetry, x equals h. And the h value is? We get this here. I would prefer that you do, because here it won't be too big of a difference one way or the other. But especially when we get to where it's wanting the axis of symmetry and the directrix, because axis of symmetry is either x equals h or y equals k. Where we get x equals or y equals a number, directrix would give us also x equals or y equals. We do need a way to distinguish between those 2. Here, it's neither here nor there because we only have 1 equation. So it should be pretty simple, but I do want you to put a and s because it is shortened already because you're not having to write out axis of symmetry for each one. So at least give me a of x or directrix to signify which one it is. Questions on number 6? Number 8 is starting out in what form? X squared plus 2x minus 1, is that in vertex form or standard form? Standard form. The values of a, b, and c will not contain variables. A, b, and c will never contain a variable as part of its value. And the vertex is what we're finding. And the axis of symmetry. Now the vertex for standard form is negative b over 2a, comma f of negative b over 2a. And the axis of symmetry is x equals negative b over 2a. Now I'm not expecting you to write out the general form on the test or write those out. I'm just putting them down as a reference to what we're solving. So again, these here are all included in the reference sheet in your review sheet. But the first thing we need to find the value of is negative b over 2a. Well, what's the value of b? 2. Because the b's value is in front of x. So it's our plus 2, our positive 2. What's the value of a? What's the number and where's a at? in front of the x squared, it is 1. And what would c's value be? -1. We don't need it for this, but c is indeed -1. And I can tell you right now, a for these here will never be 0. Because if a is 0, we do not have a quadratic, so none of this works. So at this point here, now we just need to simplify. Well, we can grab a calculator. -2 over 2 times 1 is -1. If you want to simplify, especially in the numerator, the negative, if we have, say, -2, you could simplify it to 2, or you could just type it in as negative, parentheses, -2, close parentheses. So that does give us the x value of the vertex, because it's -b over 2a, comma, f of -b over 2a. And the axis of symmetry is what? X equals -b over 2a. So we already have the axis of symmetry. X equals -1. Now to find the other part, our f of -b over 2a, all that's saying is that we're plugging -1 back in for every x. So x squared would be -1 squared plus 2 times -1 minus 1. So in the calculator, 1 squared plus 2 times -1 minus 1. And we can hit enter. Now, especially if we're squaring a negative, we do need the parentheses around it, because -1 squared is not the same thing as -1 in parentheses squared. Because if you don't include the parentheses, it sees it as -1 times 1, not -1 times -1. So the vertex is the point -1, -2, and the axis of symmetry is x equals -1. Any other questions on these here? Any other questions on 6 through 10? (11 through 15, we want to find the direct axis of symmetry and the focus. We didn't ask for the vertex, but that's fine. And to find any of these here, we need to find the values of h, k, and p. Now, I would attach this to the general form. Well, the general form would be y equals 1 over 4p times x minus h squared plus k. So what would the value h for this be? H is inside the parentheses. Do we have? It would be 0. K would be 0. Questions on how we found h and k? Now we need to find the value of p. Well, p is equal to 1 over 4 times the number in front of the term being squared, which in this case would be -1/12. And again, we can do this in a calculator. 1 over 4 parentheses -1 over 12 is -3. So the value of p is -3. Bless you. Now, with focus, directrix, and axis of symmetry, I would again advise you to keep looking back at the general forms to make sure you get these right, because the focus is the point for y equals h comma k plus p. But we know the h value, it is 0. Which is -3. So the focus for this is the point 0, -3. And we could have plugged that into the calculator, said 0 plus -3, let it do it for us, and get our answer. Because our -1/12 is the simplified version of it with plugging p back into the equation. But our value p itself is -3. Now we do need to find the directrix, which is y equals k minus p. So 0 minus -3. Negative negative makes a plus. Y equals 3. And the axis of symmetry is x equals h. Well, our h value is. It didn't ask for it, but what is the vertex for this here? 0, 0, h comma k. Just make sure you don't flip the h and k values for that. Any questions on any of this here? What are h and k for this here? 0 and 0. Because we don't have a set of parentheses, so there is no k value. And we don't have anything added to the end, so there is no h. But we do need to find the value of p. P is equal to 1 over 4 times 1 over 24. 1 over 4 times 1 over 24 is 6. Focus. Now for us, because we have x equals, the focus is the point h plus p comma k. Well, our k is just 0. Now we do need to calculate h plus p, which in our case would be 0 plus 6, which is just 6. So the focus is 6, 0. The directrix is the equation x equals h minus p, which in our case would be 0 minus 6, which is x equals -6.
Wait, the direction 0 minus 6.
And axis of symmetry is y equals k. And that's it for that there. Questions on any of this here? We ready for the next type? Because I think we feel pretty comfortable with these here. Now on the test, you're not going to be given any problems where you're not given the vertex or focus and so you're not going to be given one that just has focus and directrix. If there is one that shows up, I will tell you what the vertex is. But we'll be given at least the vertex and focus or vertex and directrix. Vertex is still h comma k. And to find the equation, we need the values of h, k, and p. Now, directrix is kind of nice because it tells us almost immediately which one we have. Y equals 2. So the general equation is our y equals 1 over 4p times x minus h squared plus k. Because in the two forms, directrix is either y equals or x equals. We don't have to look any further than that. So we can plug the zeros in. So we have 1 over 4p times x minus 0 squared plus 0. Now, 1 over 4 times the value in front of the parentheses if we're going from the equation to the information. Now, what we're told in the general form for the directrix is y equals k minus p. Now, if we plug in the value of k and the value of p into the equation, for this one here, we should get a value of 2. Now, we know what the value of k is. It is 0. So we're saying 0 minus p is 2, or that negative p is 2. Divide both sides by negative 2. Well, negative p divided by negative 1 is positive. 2 divided by negative 1 is? Yes, we could have also times by negative 1 and got the same thing. Now we could plug that into the calculator. 1 over 4 times negative 2 to simplify that and get negative 1/8. Our x minus 0 squared is going to work out to be just x squared. So we get y equals negative 1/8 x squared. Questions on this here? Questions on anything we've done so far? If you want to work on this one here, later I'm going to tell you the vertex for this one here is also 0, 0. But the next one I want to look at is problem number 18. 18. They give us the vertex. Vertex is still the point h comma k. So that's telling us h and k are both 0, 0, and 0. Now the focus is either h plus p comma k or h comma k plus p. Which of the two values stays the same? Why? So in the vertex, k is, in the focus, the second value is still 0, yes? So that means this still has to be just k. The x value for the vertex is h. H is 0, yes? In the focus, it's now negative 10. We added something to that value for it to change from vertex to focus, so this would be h plus p. Does that make sense? Now to find the value of p, we would end up setting h plus p is equal to negative 10. What's the value of h? So 0 plus p is negative 10. Really, we're saying p is negative 10. Questions on how we found hk or p? Now the general form for this here, would it be x equals or y equals?
No, x equals, sorry,
So I would match up our focus, h plus p comma k goes with x equals. Because if we're going from vertex to focus and the x value changes, we're x equals. If the y value changes, it's y equals. Now we can plug our values in because we have 1 over 4 times negative 10 times y minus 0 squared plus 0. Now we can plug our 1 over 4 times negative 10 into the calculator, let it do it for us. It should give us negative 1 over 40. Our y minus 0 squared is actually just going to simplify down to y squared. And we get this here. Questions on any of this here so far? We ready for the next one? Do you feel pretty comfortable with these here? That leads us to 20 through 23. You don't have to write the general form above it or below it. I do this here to help us match up our h, k, and p. Because once we find the values of h, k, and p, we can find the vertex, focus, directrix, and axis of symmetry. So looking at this here, what would the value of h be? So h would be located inside the parentheses, yes? The number in there is 3, and it is opposite, kind of since it's minus 3, it actually comes out as positive 3. The value of k is 2. Would it be positive or negative? Positive. And the last thing we need to do is find the value of p. P is 1 over 4 times the number in front of the term being squared, which is 1/8. 1 over 4 parentheses 1 over 8 is 2. So the value of p in this case is 2. Vertex in the general form is the point h comma k. So what's the h value for this here? 3, comma 2. So the vertex is the point 3, comma 2. Focus. Now again, we would look back at the general form. So y equals, our focus is h comma k plus p. Well, the h value for this is 3, so we can plug it in. K plus p, we do need to calculate. Our k value is, p value is, and 2 plus 2 is 4. So the focus is the point 3, 4. Directrix. In this case, it's y equals k minus p. Well, k is 2 minus p, which is also 2. So the directrix is y equals. Axis of symmetry would be x equals h x equals 3. Because axis of symmetry for this type here is x equals h. For the other equation where we start off with x equals, the axis of symmetry is y equals k. Questions on this here? We're ready for the next one. Now this one here we start off with x equals. So in the general form, x equals 1 over 4p times y minus k squared plus h. So we need to find the values of h, k, and p. Where's h?
Oh, it's the opposite.
Oh, it's opposite. Okay, h is
So this is also part of the reason I do write the general form back out, because when we have x equals, h and k do flip places. But p is still our 1 over 4 times the number in front of our parentheses, which is 4. In the general form, the vertex is the point h comma. Our h value is -1 comma -5. Our focus, again, I would refer back to the general form, is h plus p comma k. Well, our k value is, now we need to take h plus p, which would be -1 plus 1/16. It is -15/16. Correct x in the general form is x is equal to h minus p. In our case, it'd be -1 minus 1/16, which in this case, it would be -17/16. And again, we could do this in a calculator. We don't have to do this by hand. And the axis of symmetry in its general form is y equals k. In this case, it'd be y equals -5. Questions on any of this here? Questions on any of this so far? Yes, sir.
Oh no.
Do we feel comfortable with 20 through 23? (24 through 27). Find the equation from the given information, vertex and focus. So we need to find the value of h, k, and p. Well, the vertex is the point h comma k. Well, the h value is? Now we need to find the general equation that we're going to be using and the value of p. So which value changed from vertex to focus, the h value or the k value? H. K value stayed the same. H value changed. We added something to it. So the focus for this would be h plus p comma k. So two things it's told us. It told us that h plus p is 14. It also told us that the general equation is x equal 1 over 4p times y minus k squared plus h. Now the h value in this case is, now this one here we actually have to do, yes, we have to do some calculations. We have to subtract. So p is equal to 7. Now we're going to plug our values back in. Do be careful that you don't switch the h and k values, but the, yes, or put them in the wrong spot. Because if we do, when we do simplify, our 1 over 4 times 7 would be 1/28. We don't have any double negatives, so the y minus 3 will stay there. So we'll have y minus 3 squared plus 7, and this is our final equation. Any questions on any of this here?